So the heat absorbed is the same. So we can say heat absorbed, and they're asking for the ratio of these masses. So heat absorbed is going to equal Q equals mc delta T. So we can say that M is going to equal Q divided by C delta T. We can say that the mass of the copper to the mass of, mass of the aluminum to the mass of the water is going to equal Q over the mass of the copper, the specific heat of the copper, delta T, to Q over the specific heat of aluminum, delta T, to Q, the specific heat of water, delta T. And again, these Q's are going to cancel out, these delta T's are going to cancel out, and we're simply getting 1 over the specific heat of copper. In this case, it's going to be, for the specific heat of copper is 390 joules per kilogram per degree Celsius. This will be 1 over the specific heat of aluminum, so 900 joules per kilogram per degree Celsius. And then this will be 1 over specific heat of water, 4,186. We're going to have to multiply this all by 4,186. So we have, this is going to be equal to 4,186 divided by 390 to 4,186 divided by 900 times 4,186 divided by 4,186. And we're getting that the mass of the copper to the mass of the aluminum to the mass of the H2O is going to be equal to 10.7, 4.65, and 1. So essentially, if all of these substances or compounds or elements have absorbed the same amount of heat and have had a temperature change that is equal to one another, basically the mass of the ratios of the mass are going to be dependent on the specific heat capacities of the element itself, so this would be again assuming that all of them raised by the same amount and all of them absorb the same amount of energy. The only thing that changes is, of course, the specific heat capacity of the element. So that final answer, 10.7 to 4.65 to 1, that is the end of the solution. Thank you for watching.